In lesson number 3, we're going to talk about the circumference and area of circles, which should mostly be review, and then we're going to add one new idea because we're going to try and find pieces of a circle and the area of that piece and the arc length of that piece. So let's start with reviewing circumference. The circumference is just a fancy word for perimeter, and most of you probably remember the perimeter formula for a circle as the diameter times pi. A lot of times you'll see me write it as 2 times pi times the radius, because the radius times 2 is just the diameter. The reason I do that is because most of the time we have the radius. So let's say the radius of this circle was 4. I would then say that the circumference is 2 times pi times 4, which we're going to leave in exact terms as 8 pi. If you were more comfortable drawing another radius and saying the diameter is 8, and then just saying 8 times pi is 8 pi, that's totally fine too. But that's how we find the circumference of a circle. Recall that a central angle is an angle created by 2 radii, so this angle in my circle over here is a central angle. And the main thing you need to remember is that the angle measures the same as the arc that it intercepts. So the angle measures the same as the arc intercepted. So if this was a 70-degree arc, this would be a 70-degree angle. And we're going to use that idea in junction with the circumference of the circle to find just the measurement of a specific arc length. So don't confuse arc length with degree measure. That's a 70-degree arc, but I want to know what is the measure of that actual length, just like you would take a ruler and measure it. But you can't with a circle because it's not made up of line segments that have starting points and ending points. So how do we do that? Well, first we're going to try and figure out what is the circumference of a circle. So you need 2 things. You need the radius, so let's say the radius is 6, and then you need the central angle. So let's say the measure of this arc is 60 degrees instead of 70. That makes the central angle 60 degrees as well. Well, the first thing we're going to do is find the circumference, because the circumference would be the total length of all of this circle. So if you have a radius of 6, your circumference is equal to 2 times pi times that radius of 6, which is 12 pi. Again, we're leaving things in exact terms. But we are only interested in how far it is from the starting point of the arc to the ending point of the arc length. So what we need to figure out is how much of the circle we actually have. Well, we can use the central angle to do that. If the central angle is 60, that means the arc is 60 degrees. So if you have 60 degrees out of a total 360, that means you have 1/6 of that circle. So if you have 1/6 of all the degrees around that circle, that means the length of that arc is going to be 1/6 of the total length. Well, that we've already figured out. The total length of the perimeter is 12 pi, so the arc length is going to equal 1/6 of that total 12 pi, and 1/6 of 12 pi would be 12 pi over 6, which ends up being 2 pi. Yes, you could multiply 2 pi and say that's approximately 6.28, but I don't want you to do that. We want to talk in exact terms, and 2 pi is exactly the length rather than a rounded decimal to 6.28. And that's the whole idea. To find the arc length, we find the fraction of the circle that we have. So let me write that. We have the fraction of the circle multiplied by the circumference. And that's how we're going to find the arc length of any circle. So let's do another example, make sure you have this. So this one says find the circumference. If I give you a radius, let's say, of 10, circumference is very simple. The circumference would be 2 times pi times the radius, which would be 2 times pi times our radius of 10. So the circumference is 20 pi. But let's say I want the arc length of AB. So if I say arc length of AB, well, I have to know how much of the circle do I have. So the thing I need is the central angle. Let's say this time that the central angle is 80 degrees. If that central angle is 80 degrees, that means the arc measure is also 80 degrees. So if I have 80 degrees out of a possible 360 degrees, 80 over 360 is going to reduce down to 2/9 of the circle. So if I have 2/9 of the circle, then that means from point A to point B is 2/9 of the circumference. So the arc length of AB is going to be 2/9 of the total circumference that I had, 20 pi. And you can think of that as over 1, so that's going to be 40 pi over 9. And 40 over 9 doesn't reduce, so we're just going to say this would be the exact arc length from A to B, because it's the fraction of the circumference.